Hi everyone, this is your TA, Stephen Hill, and this is Geology 3104C. Today I'm going to give a brief tutorial on how to approach lab number 2. This is the Phylogenetics Lab. So the first thing you're going to do is you're going to have models to look at. I'm going to skip opening the models and just show you how you would fill out the chart and then do the tree. So what we're going to be looking at here is each trait will be assigned a number in the assignment. And we'll look for these traits. The outgroup is going to remain as a series of zeros. We'll talk about what the outgroup is in a second. And then taxon A, B, and C will have names in your file. And if a character trait is present, a 1. If it's not, it gets a 0. Simple binary, essentially. As you can see, we fill this out. There is the occasion where something will not have been preserved on these files that you're looking at on the animal. So that will allow a question mark, but use these sparingly, as if you use too many question marks, you're going to have a problem. So you would fill these out completely, and then you're going to have 3 trees over here. Each tree, as you'll notice, will have a different arrangement. So here is your outgroup. This would be called your in-group. So you have a check mark already distributed at the bottom here. If you wanted to print these out and do them on paper, that's totally fine, but please do it neatly because it's going to get a little messy. So you can take your check mark and basically you're going to drop this slash or check mark, whatever you want to call it, whenever you get a change in numbers. So 0 to 1, that's a check mark already there. 1 to 0, between taxon A and B. So I need to do that. Okay, from B to C, we get another change, so that's another mark. On to the next. We get another one right off the bat between the outgroup. And we don't have one between A and B because it's 1 and 1. But then between B and C, we have a change. So just like that. So you would keep going and doing this. So if you can think about this one, would I put a check mark between the outgroup and taxon A? No. Again, between A and B? No. Then I have a change between B and C, so a check mark would appear here. So as you go through doing this, you're going to fill out the entire chart and you're going to fill out each set of trees the same way. The tree is going to rearrange these. Your in-group, the out-group will always be here. So you have an out-group. Out-groups are used in cladistics as kind of like a control. It's there to kind of create like a baseline of a lesser related lineage. Your in-group is going to rotate. These check marks that we're tracking, these are actually the synapomorphies, or the traits. So the idea there's several ways to build phylogenetic trees. We are going to be talking about parsimony. This is the parsimony process that we're doing, in that we're going to count these changes in the synapomorphies. And the idea is that in cladistics, that the word parsimony, which if you Google it is going to say something like unwillingness to change or unwillingness to give up energy. In phylogenetics, it is the idea that nature will always take the path of least resistance. The simplest answer will always be the rightest one. The more correct. So at the end of this, you're going to count the amount of check marks that each tree has accumulated. And the idea being that the tree with the least amount of check marks will be your most likely outcome. And if you're still listening this far, this is such a train wreck. If you'd like an extra bonus point on this lab, email me the name of your favorite song before the end of the day Friday, and I'll see that you get an extra point on this lab. Thanks for watching.